Hello again. Let's continue with the operators now, and let's complete the bitwise operators, the assignment operators, the membership, and the identity operators quickly in this video. Alright, so we go into programming, that is Python 3, and let's understand. I'm not going to make a file, I'll write them in the shell itself this time. Let's say a is equal to 5, or let me say a is equal to 7, and b is equal to 10. All right. Now, when I say the bitwise operators, that's what we're going to go with. A and B. It says 2. Why 2? Now, we need to understand A, because A is 7, I can say A can be written as binary 0, 0, 0, 0, 0, 1, 1, 1. That's the binary of A, 7, considering 8 bits each. And then, if I say B, that is 10, it's going to be written as 0, 0, 0, 0, 1, 0, 1, 0. Alright. Now, when you do a bitwise AND, with the ampersand operator, and then it ANDs each of these bits bitwise. 1 and 0 is a 0. 1 and 1 is a 1. So, if I write A and B, it's gonna be something like this. 0 and 0 is 0, 0 and 0 is 0, 0 and 0, 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1, and 1 and 0 is 0. What is this? 2. Perfect. That's the answer. Alright. Let's go on to what would be A or B. Okay? A or B. What would A or B be? Alright, it's gonna be, okay, I'll just first say this, A or B, before going to a comment. Sorry. That's 15. How did that come? I'll write this A once again. I'll write this B once again. And then we'll do the ORing part of it. That is A or B. So that's gonna be 0 or 0 is 0, 0 or 0 is 0, 0, 0, 1, 1, 1 or 1 is 1, 1 or 0 is again 1, or is 1 if any one of them are 1, or if at least one of them are 1. Okay, enter. Now, so we got A or B. Then you have another operator called as A XOR B. Now, what is A XOR B? Again, if I copy these two things out here, copy A XOR B, that's going to be given as 0 XOR 0 is 0, 0 XOR 0 is 0, 0 XOR, oops, just a minute, 1 second. XOR is 1. XOR is 1, yeah, when any one of them are 1. So if both of them are zeros, or if both of them are 1s, it's gonna be, answer is gonna be 0. So 0 XOR 0 is 0, 0 XOR 0 is 0, 0, 0, 0 XOR 1. At least one of them is 1. Yes. Then it is gonna be 1. 1 XOR 0 is again 1. But 1 XOR 1 is 0. 1 XOR 0 is 1 again. What is that? This is 13. This is 8 plus 4, that is 12. 12 plus 1, that is 13. Okay. We now go on to the next bitwise operator, that is not of A. It says it's minus 8. Okay. What is not of A? And that's minus 8. Okay. So if I just copy A and I put it up here. Not of A or negative of A, negation of A, is going to be given as a complement of each of them. So now this is a negative number. Now this is a negative number which is stored in this particular fashion. Now if you want to know what kind of number this is, you need to get the 2's complement of this. The 2's complement of this is going to be, okay, so this is a negative number. Not of A is going to be this, and this is going to be exactly the way that it's going to be stored in your memory. But then if you want to read it, why it is -8? When you write not of A is -8, okay, why is it -8? Then you need to take the 2's complement of this and figure out what is the positive number of which this is. Alright, so it is a 2's complement. So negative numbers are stored in 2's complement form. So then I can say, I'll just write here, if I have to take the 2's complement, I will just say 0. First I need to take the 1's complement, that is 0, 0, 0, 0, 0, 1, 1, 1. And then I need to add a 1 to it. So if I add a 1 to it, 1 plus 1. So 1 plus 1 to the last bit. 1 if I add to this last bit 1. If I add a 1 to this last bit 1, what is going to happen? 1 plus 1 is 0 carry 1. 0 carry 1. This 1 needs to be added with this 1. Again, it's going to be 0 carry 1. Again, there's going to be 0 carry 1. The 1 is going to come here. So this one, I'll write it here. Now, what is this number? 8. And hence, the number that is this particular number is -8. So, this is how you read what is a negative number. Alright. Now, we go on to the next one. That is, so we saw bitwise operators and or XOR, negation, and then we have, complement, and then we have the right shift and the left shift. Okay, A right shift by 2, enter. It says 1, Y1. Okay, I'll store A, I'll write A once again, and then let's see what is A right shift by 2. Okay, what is it going to be? Each of the bits are going to be shifted to the right by 2. So this bit is going to be shifted one place here and one place here. So this bit is going to finally come here. The MSB is going to come here. The next bit is also going to be shifted by 2, which means that is also going to come here. That is also, next one is also going to come here. So these are the 3 bits which got shifted to the right. What about these 2? They also will come after that. Then comes the 3 ones. This one is going to be shifted to the right, which means that one is also going to come here. But what about the rest of the 2 ones? They are gone. Okay, they cannot be shifted to the right because this is the maximum that it can hold. What about these 2 bits? These 2 bits are going to be 0 and 0. They're just going to add. So what's the answer? Right shifting the bits by 2, answer is 1. Alright. Then we go on to left shifting bits by 2. Okay, so that's going to be a left shift by 2. Okay, so if I do that, I'm going to shift, okay, not this one. This is already shifted. I'm not shifting this. I'm shifting A by 2. So let's shift it by 2. If I shift it all over, I'm going to get like this. 0, 0, 0. Right? These 2 zeros will go off. It is not going to be there. Then it's going to be 1, 1, 1. And then zeros are going to be added at the end. Okay, this is going to be the answer. Now, what exactly is that? A left shift by 2. That's going to be 28. This is 16 plus 8. 16 plus 8 is how much? That's going to be 24. 24 plus 4 is 28. And that's right. So you have A left shift 2, that is 28. Clear? These are the bitwise operators. Now we go on to some other operators also. So that we finish up the operators quickly. Okay. By the way, where are these operators going to be used? We are going to use them maybe when you have certain data and you want to hide a few bits, you want to show a few bits, you want to do some operations where you want to do some bitwise operations on the data. Okay, on any kind of data that you get, Hence, you will use any of the bitwise operators. Okay, another operator which is going to be used very frequently is called as the assignment operators. Okay, this is not difficult to understand. Why? Because if I do a plus 2, what's the answer? 9. But if I say, what is the value of a now? It is 7, which means a has not changed. We got the answer a plus 2 because we were printing a plus 2. But when we changed a plus 2, did we assign it back to a? Did we change a? No. A was still remaining 7. Hence, you can write there. Hence, we have another, you can actually write something like this, a plus 2. A is equal to a plus 2. Now, if I say what is a, that's 9. That's right. But instead of writing this, Python says we'll give you an operator which says a. What do you want to do? You want to add it to 2 and then equate it back to a. You can write something like this, plus equal to a plus equal to 2, and a was currently 9, it will become 11. Correct? Okay,